Hello, everyone, and welcome to our user meeting number 13. Oh, that's Friday the 13th, but I'm pretty sure it will go well regardless. It's been a while since we met last time, almost a year. Yeah, many things have happened, but yeah, we are back together, stronger than ever. In today's presentation, we are going to discuss several things. Alexander will start with improvements and additions to our redesigned package manager. Then I will describe some improvements we've done for in the area of exploratory data analysis, so some cool visual features. And then Leonid will describe our efforts in the area of macromolecules support. Then Alexandra will continue and pick it up and describe the work she's done with HELM. And then Maria will tell us about the activity cliffs analysis that she has developed. After that, I think we will have at least 30 minutes of question and answers. So please ask the questions right away as well. But if your questions are not related to the topics, we'll have time in the end to address them. So let's get it started. Alexander.
Yeah, thank you, Andrew. Can I please steal your screen?
Please.
Just a moment. Okay, can anyone see my screen?
Yes.
Yeah, thanks. Let's start. Hi, everyone. My name is Alexander, and I'm a software architect in Dataglock. Here in Dataglock, we develop many features for our platform. All of them are cool, useful, but we don't want to overload the system. And of course, all the features are from the different domains, and you never need them at once in the core platform. That's why Dataglock has modular architecture, and you can choose which models do you need. We now have 42 packages in our repository. You can see them all on my screen. They are all available right away after you install Dataglock somewhere. It doesn't matter if you install Dataglock on cloud or if you run it on local machine, wherever. All packages are open source, and you're free to make pull requests, register issues, export the code. For example, you can go to the package, and here you can see the link to the package repository. And of course, all packages are NPM compatible. We use NPM, it's Node Package Manager, to maintain package releases. And all the packages, as I already said, are NPM compatible. And you can reuse features from our packages in your own packages. So how to install the package? It's very easy. You just need a single click to install the package to the Dataglock. Thanks to our release process, each package has Dataglock version constraint, and Dataglock knows which package can be installed right now. So Dataglock controls compatibility, Dataglock controls package content, and so on. You can select version you want to install. If you select latest version, Dataglock will install latest package version as we release it. So, for example, here we can see auto update is enabled. So if we release a new version for this package, Dataglock will automatically update. Of course, you can filter this view to see only installed packages, to see all packages. You can search packages by category, by name, whatever you want. Package can contain pretty much everything Dataglock can work with, and seamlessly extends Dataglock. Let me show you how it works. For example, let's open some demo file with smiles. Smiles is a notation for chemical elements. I believe most of you are familiar with it. And basic version of Datagrok knows nothing about smiles, and it doesn't understand it and treats it like a simple lines, simple strings. So let's try to install chemical package. This is a chem package. It's designed especially for Datagrok to teach Datagrok to understand chem informatics. As you can see, it doesn't take much time, so it takes just few seconds, maybe 10 seconds to install the package, and the package is available right after installing. So if you do it for the first time, you even don't need to restart Datagrok. So you just need to wait once more. Okay, chem package is installed. Let's go to files and try to open it once again. As you can see, Datagrok now knows chem informatics, and it draws smiles. Let's open the file, and now we see a lot of additional panels. They are all interactive, and they are all came from chem package. Datagrok immediately starts to show pictures and offers additional actions now. That's how we taught Datagrok to work with chem informatics just with installing one single package. All these packages are available as open source. All of them are available in our public repository, in our NPM repository, and you can find the link here. As you click on package, you can go and see what's inside. Learn, read, use contents in your own packages, and so on. We have 42 packages for basically everything Datagrok supports now and Datagrok can work with, and we constantly developing new one. Okay, that's all I wanted to show you right now, and time to answer your questions. Please ask.
And like, sorry.
Go ahead.
Please go ahead.
So I'm a very new user to Datagrok. Been working with Bill and Vijesh. Sort of. What you just showed, does that have to be done once for the tenant, or does each user need to do something similar independently? So what I noticed is that, for instance, one of the users on our tenant has the display for smiles, whereas my account doesn't.
That's a very good question. It needs to be done once on the platform, and package must be shared for all users to view. Most of the packages are shared automatically. Datagrok knows that everyone needs chem package, but you can share it explicitly. For example, right now all users can view and use the chem package, and developers group can edit this package. So they can update it, they can delete it, they can rename it, whatever they want to do. In your case, I believe it's enough to share the package with all users after you install it.
Okay, thank you.
Yeah, Alexander, thanks. That's a pretty convenient interface. So I wonder, is it currently possible to have different versions of the same package targeted to different groups of users?
It's not possible right now, but we're working on it. It's a pretty cool feature we want to make shortly. We already have multiple versions of package, and you can switch between them seamlessly. So, for example, I can switch for another version, but unfortunately, right now we cannot switch the certain group of user to certain version of package. So everyone using the same version of package, but it's possible. Datagrok architecture supports this. We just need to develop pretty UX for that, and it's on our roadmap.
I see, but at least we can easily switch between versions. So, for instance,
sure.
That's pretty cool.
And each user can have his own version of the package. So it's called debug version of package. So if you develop a package, it's useful to publish the package as a debug version, and no one except you can see it. Actually, it's yeah. Thank you for the word that UI is pretty much convenient. We used to work hard to achieve that, and there is an ecosystem behind this UI, including releasing, testing, and maintaining package releases, and it's all open source. You can use it as you want. Any more questions?
Okay, thanks, Alexander. If there are no more questions, let's move on to the next topic.
Yeah, maybe they will be after all the presentations. I will gladly ask. I'm here until the end.
Okay, so next up are my updates regarding the improvements for exploratory data analysis and other generally applicable things. So we had multiple demos previously. Actually, I believe at least 3 of them were specific to exploratory data analysis and visualizations. So for that, you might want to rewatch our previous episodes. But we constantly build new features. So today, I just want to advertise a few of the nice features that we've built recently. So I'll start with the automatic distribution profiler for exploratory data analysis. I have my favorite demographics dataset opened on a screen, which can be visualized in different ways. Different subsets of rows could be selected, and of course you can interactively filter it using multiple ways. So what we've decided to build is a really easy and unobtrusive way for seeing the differences between the subsets that you currently are looking at and the subset that you have selected versus the all of the data set. And in order to trigger it, well, you pretty much don't have to do anything special other than select some rows. Now, for the frequent users, remember that, but I'll explain to the new users. The area on the right is our property panel that tracks whatever object you click on. For instance, I'm clicking on the columns, and we see column information, and we can drill down to all sorts of details. But when we change either the selection or filter, this panel automatically switches to the selected rows. I just selected rows, that's why it's shown here. And what we have added is the distributions pane, which by default shows the distributions of all numerical attributes in that column, split into 3 or more lines. One for selected rows, so this histogram is selected rows, then others, and also all of the saved sets. So we have this Boolean column controls are also included. So it is really easy to compare the distributions and see where statistical differences arise. Notice how I select things and distributions get different. the same way I would achieve it if, for instance, I just start sliding the filters. As I move them, we see all sorts of differences emerge. Personally, it's one of my favorite tools that I use for initial data analysis. Any questions on that profiler? Okay, I think it's self-explanatory, which is how we want it to be. Another minor feature that we've recently added, and this is, by the way, part of the Power Grid package. Now that everything is packaged, thanks to Alexander, it's quite simple, is we provided automated support for images in cells. And this is the content of the file that I'm going to drag and drop to the platform. One of the columns contains a hyperlink to an image. So in order to see it, you only need to open this file. Bam, done. Nothing really impressive, but it's one of the features that really makes your life easier. And we support the URLs are getting automatically detected. And we also support images in cells. I'm not going to show it. We have it in the documentation. In order to do that, you create a column with the image cell type, and then you can double click on the cells and embed images like PNG files, BMPs, GIFs, and so on. Any questions? Okay.
There is a question in the comments. What about base 64 encoded images?
So we have embedded images. So they are not base 64 encoded. They are actually they're just binary encoded, which is more efficient. So yeah, Gregory, I'll make sure to send you an example how to do it and refer you to the documentation part. So it's supported now. Yeah.
Andrew, I have a question. So we have a new software that has to deal with images. We have it as an RPod, but we're actually publishing 2 papers, and so we can just use the methodology, just to write the code in whatever language you're using. I was just wondering if it would be possible to integrate with that DataGrok. We are going to make it as a standalone Shiny app, but looking at your software, I'm thinking maybe integration would be a bit, because you have a lot of things on the background, like databases, databasing images, all that stuff. It could be an interesting approach. I'm just wondering how open you would be to integrating something like that.
Oh, we are super open regarding that. Yeah, let's take it offline. Let's talk about it. And so we have our open source repository of scientific extensions, which this project that you mentioned might just naturally fall into. And what's great, it would be usable either standalone, even without DataGrok, but then it would be automatically integrated in DataGrok by just introducing a tiny header on top of it. Yeah, we've also discussed it in one of our previous meetings, this approach. I'll send you a link, but yeah, okay. That's great.
Thank you. Yeah, I'll connect with you after the meeting. Thank you.
Yeah, fantastic. Thanks. Okay, the final thing I wanted to show today is also another way to visualize data, specifically high-dimensional data. So let's open some data set. It contains some information on volcanoes. Not exactly sure what the columns mean, but that's not critical for our purpose. The thing is, oftentimes we see wide data sets with tons of columns. Each of them has a meaning, but it gets lost. It's really hard for human eye to perceive differences in numbers. Then, of course, there are ways to visualize it and even visualize it in a multi-dimensional space. And Datagrok is really good at it. But what we've also recently built is a way to quickly summarize each row visually. This approach is typically called Sparklines. And the way it works is that you would select a number of columns. I'm control clicking on the header to select multiple columns. As usually, we would see that information on the right panel. I think I'm opening. Sorry, I got the wrong tab. Let's get our columns. And one of the options that we see on the right is Sparklines. Well, assuming you have the Power Grid package installed. You click on it, select the type of Sparkline, and you might want to even hide the corresponding columns. So let's hide them. And we want to make it, well, a Sparkline. And this is the summarization of data containing in that columns. In this case, it's a line chart, and each point represents a value in the corresponding column, and you can scale them either globally. So you want to use global scale if it's the same units, or locally, meaning each column is normalized according to the minimum and maximum values in that column. And you see exactly what are the points. For instance, here I can see that the last point, V9 column, is in the middle of the range of the corresponding column. So by just glancing at it, you see a lot. There are also different types of Sparklines. Some of them are more useful and different than others, and they are used for different purposes. Radar plot, where each column gets put on the radius, again according to the value, where minimum value falls in the center and maximum value of the column falls on the outside circle. And there are many ways to analyze it. For instance, you might just want to see the profile, well, of either your chemical compound or whatever you have in the row, and see how it corresponds to the average values or just the overall shape. Another way to analyze it is you might want to sort by any column, and then simply by scrolling down, you see how the profile of your object changes as this value grows. So, as you can see, there are multiple creative ways to do things. We also support two more Sparklines. One is a bar chart. Essentially, it's somewhat similar to the line chart, but you have bars instead of points. And the last one would be our typical pie chart, where we can code the value as either the length of the radius or the angle, in which case you see the proportion of each value relative to others. Customizing a radar Sparklines is easy. You either click on a column and the settings appear on the right. For instance, I might want to color code each bar. Alternatively, you can click on this hamburger menu and the same properties would appear. It allows you to change the columns that belong here and edit different other options. Any questions regarding the Sparklines? Oh, I see a question from Gregory. Thanks. How are missing values handled? Missing values are handled differently in different Sparklines. So in the line chart, we would see a line that connects, for instance, if we have a value in the middle is missing, we would see a line between the previous to the next one, but no point between it. Then for the radar plot, it would do the same. So we'll see this segment going from first to third, skipping the second without a point on it. For the pie chart, just nothing would be displayed, so it's functionally the same as 0. And for the bar chart, it's also nothing would be displayed, so it's functionally the same as 0. Thanks, Gregory. Got your message. If there are no more questions, we'll switch to our next presenter, Leonid, in a couple of seconds. Going, gone. Leonid, please take the stage.
Yes, hi everyone. My name is Leonid, and I am researcher in research scientist in DataGrok. And as you know, DataGrok provides cheminformatics supports for small molecules, and one of our current aims is to enhance its capabilities for macromolecule entities. In this presentation, we will look through 2 comprehensive examples for that. So let me open a FASTA file. Sample FASTA. Oh, sorry. Sorry for that. Just a second.
Leonid, are you looking for a FASTA file?
Yeah, FASTA
It's
file.
in the first column. In the first column of the files.
Oh,
this.
yeah. I wanted to open the CSV, but well, actually, I think that will work as well. So yes. As you can see, the platform has detected this notation. FASTA file usually contains only natural, amino acidic, or nucleotide sequences. And in these examples, they are rendered in the way by the different charges of the monomers. All the features related to this column appear in the bio tab of the top menu. So it is here. For the first step of analysis, we can run multiple sequence alignment. Let's do that. And here we will get a column with the line sequences and can now compare their similar regions. So these features has limitations for now, but as it works only with natural residues, but we are going to enhance it. And we are focused on processing any given non-natural sequences. And we are going to perform this type of analysis for different subgroups of the dataset. You can actually use other dataset representations. Let's look at composition analysis, again, in the top menu. And here we can just move it look smarter. So the web logo visualizes a graphical representation of multiple sequence alignment, and we get each composition for each position. Each logo consists of stacks of symbol, though, and it is maybe one of the most helpful features for exploration analysis of your sequences. Datagrok has an ability to control the selections using this web logo. So if you choose one or any other residue, you will get the selection. Your data set will reflect this selection, and you can then filter it or remove. Another way to represent the data set is to perform the splitting. So for that, we can call the property panel, and here use biosplit to monomers. And in this case, you will get the table of the monomers, and you can inspect it for each position. Our next example shows the work for previously aligned sequences. It is in sample MSA. As you can see, all the residues here are non-natural, and it is possible to make your investigation more precise if you recover the atomic level representations of this molecule. So with to atomic level, again in top menu, you will get with this tool to atomic level, we use monomer structures from your sequences to reconstruct the initial atomic level representations of molecule, and you will get them as a column of mol V3000 notation. If your dataset contains activity values associated with your sequences, you can proceed to do different sequence activity relationship analysis just in here. Oh, sorry. So you can do different data transformations, and it will be shown as a distributions for here, and then just push run. For here, you again get the detailed table of the monomers with their structures, and the analysis for position versus monomer. And in this case, let's just click on that. We will get the distribution of the subset for this residue in the 12th position versus all other data set. And we can even compare the substitutions that yield to the activity differences in this panel. So for example, for these two cases, the substitution of this residue to this residue will yield to this activity difference. So that is all for the basic features, and my colleagues will proceed to show special cases and calculations, and your questions are welcome. Thank you.
So what else can we do with sequences? What else is in the bio menu?
Oh, here we have multiple sequence alignment. It works for natural sequences, and we are going to implement its functionality for non-natural sequences. There is sequence activity cliffs, sequence space, but I think that Maria will focus on these two features. We can reconstruct the atomic level representations, like the mol files. We can do composition analysis to show the log plot, and we actually can convert them as monomer libraries. So if any other questions will appear, I will gladly answer them.
Yeah, I think we can pass the stage to Maria then. I'm eager to learn about the activity cliffs. I know she's been doing some work there.
So that's my turn now, because by the agenda, Alexandra should. Okay, but that's okay.
Oh, sorry, I didn't want to interrupt. I just thought someone next should take the stage.
But maybe I can, Alexandra.
Yes, it's better for you to take the stage because there are some functions you should show right now.
Okay. I will try to share my screen. Actually, I've never done that before in Zoom, so that's my first time. Just
You succeeded.
tell me if you can see my screen.
You're good.
Yeah, we can see.
Okay, okay. So my name is Maria, and I'm a developer at Datagrok. And today, actually, I want to show you two tools which are applicable not only to sequences, but also to small molecules. And they can be found in both a chem package and a bio package, which has been shown by Leonid just right now. And the first tool is named ChemSpace, chemical space. And what it does, it takes the high dimensional molecule data and plots it on two-dimensional scatter plot. Yeah, I'm not sure. Sorry, everything is okay. Everything. Do you see my screen?
Yeah, everything.
Clearly, because
everything is perfect.
Sorry. Yeah, this tool can be found in a top menu. If you have the chem package installed, you can go to chem and choose chemical space. Let's take a quick look at the parameters. So you need to choose the molecule column. You can choose from several methods, several dimensionality reduction algorithms, and also you can choose from several similarity metrics. I have already ran the function now, and I have used UMAP algorithm and Tanimoto metric. And the result here is scatter plot. And we can see the groups of molecules on it. And the molecules are placed in such a way that molecules that are similar in structure, they are placed closer on a scatter plot.
And you demonstrate it, Maria, by just hovering over the points? I think we should see it in the tooltip.
Yeah, actually, this scatter plot is fully interactive, and we can see the tooltips when we hover over the point. And actually, I wanted to show some more functionality, and this can be quite convenient, for example, for subsetting. We can select the group, the cluster of similar molecules, which we are interested in potentially. And the lines, the rows, will be automatically selected in our initial table. And for example, we can then just extract the selected rows and look closely at this exact molecules cluster. So here we can look at how similar the molecules are. And so
yeah, they're pretty similar. I think. Can we take a look at the other cluster? Would they be different?
Let's try. Which one?
Just hover your cursor over.
Okay.
Okay.
Should I take this one?
That's enough.
Sorry.
Yeah, it seems to work.
Okay. Okay. So that is how it looks like. So the main point from my side was that we can choose these clusters, we can explore them, or we can select them, we can filter by them. So everything you need to do for your analysis. And actually, this functionality is fully supported by bio package, and you can find it in a bio tab in the top menu, and it is called sequence space in this case. And the picture here, I also already ran the function, and the picture is quite similar. So we have these groups of similar molecules on a scatter plot. So that is basically how sequence space and chemical space works. And are there any questions at this point? Okay, so I will then proceed to another tool. It is, I guess, even more interesting because it's more advanced and it allows you to analyze the molecule data, the molecule structure associated with molecule activity. And it is called activity cliffs. And what it does is that it detects pairs of molecules in your data set, which are similar in structure, but have quite significant difference in activity. You can find activity cliffs function also under the top menu for a chem package, for example. And let's take a look at the parameters. You need to also select a column for molecule, activity column. You can choose from several dimensionality reduction algorithms. And this similarity cutoff, you should set the similarity cutoff. And what does this parameter means? The pairs of molecules which will have similarity higher than this cutoff will be detected by this tool as so-called cliffs. And these pairs of molecules will be connected by the line on a scatter plot. We will just look at it right now because I have already ran the function, and the result is also scatter plot with groups of molecules on it. But on the top, we have the link with the number of the detected cliffs. Let's click. And the table opens in the bottom of the page. And this table contains the list of all detected cliffs and detailed information about each pair of molecules. We can click on some row, and the scatter plot will zoom in to the selected pair of molecules. And at this moment, we can take a look at the property panel because we have some information on that regarding this, about this pair of molecule. We have molecule structures for both, and common substructure is highlighted. We also have activity levels, and we have cliff level. And the cliff level here is the ratio of activity difference and the molecule similarity. And please notice that we can choose one or other structure, and the corresponding row in the initial table becomes current. So you can, by clicking on one or other, you can easily find information about this molecule in the initial data set. And also this information is available on a tooltip when you hover over the structure. Also, The pair of molecules, the so-called cleaves, can be selected by clicking on the corresponding line on a scatter plot. And if you look on the activity cleaves table, as I change the current cleave, we can see that the activity cleaves table is automatically scrolled to the corresponding line. So that's quite easy to find information about the cleave of interest, the pair of interest. And finally, I want to talk a little bit about the markers. And the marker color here corresponds to molecule activity. The red is for higher activity, so the blue is for lower. And the marker size corresponds to maximum activity cleave for this molecule, detected activity cleave for the molecule. And also you can notice that the line's opacity differs. And the line opacity corresponds to the activity cleave for the pair of molecules. And the higher activity cleave we have, the lower opacity the line will have. And this functionality is also fully supported by BioPackage and can be found in a BioTop menu. Yeah, and it looks quite the same as in Chem package. So the full functionality is available. Basically, that's it from my side. Yep.
Yeah, that looks really nice, but can I include additional arbitrary columns into the activity cleaves table in the bottom? Not just the activity, but
in the activity cleaves in this one.
Yes.
Yeah, for now, it's like, yeah, it's hard coded, yeah, for now, but yeah, sure, it can be done. It can be done. We can include any columns, any values that we need to explore with this pair of molecules. Sure. If this is available information, so why not?
Yeah, that would be useful. So another thing is, can we now start exploratory analysis for the activity cleaves table that was generated? So to drill down and find the actual pairs of interest within the 90 cleaves that you found.
Not sure. Not sure.
Okay, so we just need to add this option if it's not there.
Okay, okay, agree. Oops. So yeah, that's it. I hope that these tools can be very useful for your molecule spaces exploration. And if there are no questions, I can pass to another speaker, to Alexandra. I will stop sharing them.
Okay, maybe I should start. Okay. Right now, you should see my screen. Is everything all right?
Yep, we see it.
Okay, my name is Alexandra and I'm a developer here at DataGrok. And today I'd like to show you the plugin that works with the sequences in HELM mutation. As you know, you can present molecules in different formats such as smiles, inchi, and others. However, HELM notation is a more convenient way of molecular representation. With HELM, you can record any polymers, both peptide and nucleotide sequences, as well as various chemical modifications that can be connected nonlinearly. And the main purpose of my presentation is to show you how we integrated that in DataGrok. So we have an application that can firstly detect and identify HELM notation, secondly, render, modify, and perform calculation on it, and thirdly, add information about monomers that want to retrieve. So I've opened a file with sequences in HELM notation. Here it is. As you can see, our platform can detect HELM values in the dataset. At this stage, you can see the sequence that is colored in red and gray. So what does it mean? Red tells us right now that our platform doesn't have information about monomers that are included in this sequence. So what should we do? For the molecule in 2D way to appear. So we need to open a property panel right now. So here it is. And to find the title manage libraries. Here we can see that there is a list of uploaded libraries and libraries that are not used right now. So we can load a library with information about monomers. I clicked on load library and right now you can see a window. So there is a list of libraries with monomers and information about them. So some of their properties like air groups, symbol name, and others. So all I need to do is to click on the library I'm interested in and to upload it to our platform. I'm pressing on OK button. And right now, as you can see, everything is rendered because right now our platform knows about all the monomers that are present in the sequence. Right now, I can double click on the cell and open an editor. Here it is. So for instance, in this tab, we can see some monomers that were added. So let's have a look. This looks like that. Also, we can filter monomers. For instance, let's type something, C symbol, and we filtered our monomers. Here it is. Also, we can work with our sequence that is present on the screen. So we can add a monomer to it. For instance, I want to add alanine. So I clicked on it. Then I should click here and add it to our sequence like that. Everything is added. Also, I can select a part of the sequence like that, and below you can see monomers that I selected. Here is the representation, HELM representation. Also, you can get a structure view of what I selected before. Also, I can zoom, unzoom, and move the sequence everywhere I want. Okay, so right now I can press on OK button and everything is changed in our cell. So right now you can see that alanine was added here. Of course, we can get some information about the sequence. For instance, we can get the mol file of it. So here it is. And some details. We perform calculations for our sequence in HELM notation, and we can get the formula for it, molecular weight, and extinction coefficient. So these are our features for HELM app. Thanks for your attention. Okay.
Alexandra, can we manage libraries that are already linked to the platform or unlink them?
Yes, of course, we can manage libraries. For instance, you can add library. We have such a great feature that helps us to manage files. Here it is. It even opens HELM and libraries folder for us to add whatever we want. So we can manage custom monomer libraries, of course.
And there is a question from the chat. Do you handle cyclic peptides?
Right now, I guess no, because we work with linear structures.
I think that for the HELM functionality, we handle cyclic peptides, so you can just show the example to edit any of them.
Okay.
And concerning the other functionality for space, for activity cliffs, and for structure restoring, we are going to use the special fingerprints, specially developed for cyclic structures, so that are represented with graphs.
And actually, yeah, Gregory, so there are, it's two answers to that question. So we handle it in a way that it would get recognized and it would get rendered. But then, of course, we have a subset of analytical methods that are specific to linear peptides. Of course, that is not going to work out of the box. But Alexander, if you can edit any of the sequences, just double click on it.
Yes.
And I think if you connect first to 16th, it will become cyclic, right?
What?
Draw a bond from 1 to 16.
Oh, this will work only if the monomer has the third
like that.
group.
Yes.
Oh, all right.
Yeah. Now
It will work. Yes.
yeah.
But we're talking, I guess the question was more about handling the cyclic peptides. Okay.
Mm-hmm.
Here
Yeah, I mean, there is value in even visualizing it and being able to edit it. Then most of the analytical methods that we currently have are associated with linear peptides and polymers. So that's a great start, Alexandra. I wonder what can you describe what our plans are in this area, future plans?
I guess we haven't discussed them. We're going to discuss new features, and we are going to implement similarity and diversity search. As Leonid had told, we are going to implement a special method to calculate fingerprints. So right now we can get a mol file for our sequence, and then we're going to have a special method to calculate fingerprints, especially for the HELM mutation. And then based on these fingerprints, we're going to perform similarity and diversity search.
Awesome. And I think we were also planning to have the subsequence search, right? Similar to substructure.
Okay.
Yeah.
And substructure, of course.
Yep. It's all coming in the next versions. Thanks. Okay, if there are no more questions to Alexandra and general questions regarding HELM, we can open our general Q&A session. Ask away any questions that you might have about the platform, questions, ideas, complaints. We are here to help. By the way, here are all the different references that you might use in order to learn the platform better. I would recommend going on the community, and from there it's also possible to find the content on our previous user group meetings. So in case you miss something, just go here and find the corresponding set. Okay, great. If there are no more questions, then we'll give. Oh, I see something popped up in a chat. Oh, Gregory, thanks. Thank you. Well, thank you for joining. It was good. From now on, we intend to keep our regular cadence of meetings, which is once every 12 weeks on Friday, 9 a.m. Eastern Time. You are more than welcome to reach out to each of us individually, to me, or post a question on the community forum, visit our YouTube channel. More exciting things will be coming soon. So with that, thank you, everyone. And I hope to see you in 12 weeks.
Thank you.
Thank you for visiting, and bye.
Hey, bye.
Thank you. Bye.
Thank you.
Thank you. Bye.
Bye.